Well, good day, viewers. Today we have a 2017 GMC Sierra 4x4, and it's here because the four-wheel drive doesn't work. And I see there's some messages on the dash: service four-wheel drive. Let's see what else comes up. Service StabiliTrak. Okay, service four-wheel drive and service StabiliTrak. I heard its shift take place. Well, we're going to scan it first off and see what codes it has to offer. So this is a new vehicle record. Never scanned this before, I don't believe. Apologize for the glare. Haven't brought it in the shop yet. Should auto ID. 177,000 kilometers. Let's do a network code scan. You mentioned a couple of U network codes, U0102, U0403, but I'm not sure what he's using. Interesting. Got a fuel pump driver code. P0129D, fuel pump driver control module, ignition on, start, switch circuit, low voltage. Lost communication with transfer case control module. Invalid data received from transfer case control module. Battery voltage below threshold. Low voltage codes in the BCM. Ignition on, start, switch circuit, low voltage. Trailer brake control relay. Trailer brake control, trailer brake control, trailer power. Now I don't see any communication with come on, you can do it. I don't see any communication with the lots of low voltage codes in history. Lost communication with HVAC. Tire pressure. Battery voltage. Transfer case. So there was communication with the transfer case. Transfer case range position sensor circuit signal invalid. And P129D manufacturer specific. Okay, so we've got a record of these codes. I have no idea how long they've been there, so I'm going to clear them. I don't care about freeze frame data in this situation. I'm going to clear all the codes out, and then we'll do a network scan again. So according to the code clear event, it failed to clear the codes out of the ABS. So let's go into the ABS and see what we've got. Lost communication with the transfer control case control module. That's interesting. Let me see if we got communication with it. Pulled codes from it. Transfer case. Codes menu. Display codes. DTC display. So how is it possible that the ABS module is complaining about a loss of communication with it, yet we can scan it? Are there two networks to the transfer case control module? So I attempted to clear the codes in the ABS, and they did it with it running, and it said it could not clear the codes. So I think that communication code is a history code. So I'm going to try clearing it with the key on, engine off. So let's try clearing the codes in the ABS with the key on, engine off. So I suspect we'll have that invalid data. No, we still got the lost communication with transfer case control module. Invalid data. This is because of the code in the transfer case. That's interesting. Well, I think we're going to explore the transfer case code first. It is a C0392, transfer case range position sensor circuit signal invalid. Current DTC. Warning indicator requested. So let me do some investigation as to what causes that code. So I did find a couple of bulletins and TSBs on it. One had to do with pin grip at the TCCM, the transfer case control module, and another one had to do with missing seals on the wiring. In either case, I looked at the troublemaker chart for C0392 and it suggests a problem with the transfer case range position sensor circuit performance, either low voltage, high voltage, or an incorrect frequency. A little bit of a description. It receives input from the transfer case gear position sensor, also known as the range position sensor or the rotational position sensor. I think it's a Hall effect. The gear position sensor receives 5-volt reference signal from the transfer case control module. In return, the gear position sensor sends the transfer case control module a variable pulse width modulated signal indicating the position of the transfer case. The gear position sensor works in conjunction with the range actuator position sensor inside the transfer case motor, also known as the transfer case range actuator, to confirm transfer case position. The gear position sensor is more sensitive than the range actuator position sensor and is able to indicate the transfer case control module the exact position of the transfer case between range changes. It's also able to show how much clutch activation is being commanded. Conditions for setting it: the C0392-08 senses the transfer case range position sensor voltage that does not constantly change but remains low at less than 0.25 volts, indicating a short to ground, or a transfer case position sensor voltage that does not constantly change but remains high at greater than 6 volts, indicating a short to voltage. Shifting will be disabled. Clutch torque increased to maximum torque. Service 4-wheel drive indicator message illuminated for the remainder of the current ignition cycle. So I printed off some electrical diagrams. We've got to get this up on the hoist and have a visual inspection of these wires at the transfer case itself, and hopefully we'll find something visual. So we're underneath this truck and looking at the transfer case. This is that position sensor right here. It's like a Hall effect sensor, but it's got some electronics in it. See, it's got a brand new actuator, dormant actuator on it. Imagine that. That obviously didn't fix it. So I've got a pin out of these connections. The wires look okay. Let's get the wiring diagram. So the middle pin is the signal, and the signal is pin B, and it's signal is pin C, and it's white and green. So this is the signal wire right here on the outside. 5 volts. Ground, or ground is the outside, yellow and black. Yeah, yellow, black is ground. Okay, so we're going to pin out some voltages on here. So I've got my ground on the transfer case, and I'm going to pin the yellow black wire, which is ground. That's 0.1, back pinning. Now the middle wire is supposed to be 5 volts. I'm just inserting it now. And we've got 0.67. And then the third wire, the white-green wire, which is pin C, is a signal. And that's supposed to be duty cycled, or pulse width modulated. And I've got 4.3 volts on there. So either the 5-volt reference is open, this is the 5-volt reference in the middle, and it's 0.66 volts, or the sensor is pulling it shorted to ground. The way we're going to know is to unplug the sensor. I got to get a pick tool to
get this release clip off. I'm going to unplug the sensor and pin it with it disconnected. So that is pin B on here, which is the 5-volt reference. I can hardly see this printing, it's so fine when they printed this diagram off. I'm going to double check that. Pin B, 5-volt reference, white and red. Disconnected, it reads 3.76. So is there a problem in the wiring? I'm moving the wires up. Oh, look at that. I saw a fluctuation in the voltage. Maybe it was just my pin though, or my ground. No. Okay, it should be 5 volts on that middle pin. And on pin C, which is the signal, I got 4.35 volts. On pin A, which is ground, I got 0.00 or 0.01. So we need to qualify this 5-volt reference. That's it right there. 3.18 volts is not adequate. Unless the wire is compromised right here. I'm going to get a magnifying glass and look at that. So I was manipulating this wire and I noticed a fluctuation on my meter. I'll graph it here again and I'll manipulate the wire right at the connector. So that terminal is broken in the insulation right at that connector. Let's shut the key off and disconnect that terminal. So you can see that wire compromised right in the middle when I twist it. So we're going to see if we can get if I have a connector like this and I can repin that terminal. So remove the secondary lock, remove the insert in there, and then that middle pin is what we're going to push out. There's a plastic lock there. Push it towards my thumb and then push the pin out. I need a coffee this morning, I'm shaking too much. So there's the terminal, and this is a map sensor connector off of an engine job that I did where the used engine came with a partial harness on it. And this actually plugs in. So to service this terminal, pry this secondary plastic piece out. Pry this secondary lock off. I could just splice 3 wires, but I'd rather just replace the one terminal, because then we don't have any non-factory connections. Take the secondary lock off. Okay, now to get the terminal out of there, I'm just going to take the one on the end because they're all the same. Push in on this release. Let me turn my light on here so I can see. That didn't help much. Push away from the terminal with the plastic release, and then to pull the terminal out. So these ones are actually plated, so that should work. We're going to splice. We're going to reinsert this terminal and splice one wire. So I got the wire spliced and heat shrunk. I haven't taped it up yet. I wanted to make sure it was working. And with the key on, I got 5 volts, 4.99 volts on that wire. Let's plug it in and see what happens. In, taped up, back pinning it now. You see 4.99, 4.98 volts on the sensor signal wire, the middle one. The white green wire is the sensor signal, and you can see it is a duty cycled or pulse width modulated signal as they explained in the service literature. So we're going to clear the codes now. I'm going to secure this wiring harness so that it doesn't vibrate, because I think that's why it fails. Because if you look at this harness, it's just flapping out here like this, and it's sitting here vibrating like that. Actually, it would have been good if it was long enough. Well, maybe I could tie it to the back of this motor. Yeah, I'll do that. I'll put a tie wrap around it so it stops it from shaking and vibrating. So I noticed that the service four-wheel drive message is still on the dash, but it could be because there's codes in there, so we're going to clear all the codes, key on, engine off. I have a clean battery charger on it. It's only at 9.6 volts. Why is it only 9.6? Must be a bad connection to my battery charger. So my battery charger wasn't making a good connection on the ground. Put a vice grip on it. So let's go back and do a network code scan again and see if there's any codes. I don't like the invalid data received in the ABS module. Invalid data received. Let's see what else we got. We had that U code U0403 before, but we also had a U0102 low voltage code because of the 9 volts. Had the key on for several minutes without a battery charger on it. So let's re-clear the codes. I'll just go into individual modules. Low voltage code in the radio. That's why it's so important to have a battery charger on these things, and it has to be a clean battery charger. If you just put a regular fast charger on, sometimes the set fault goes for voltage too high because it sees the key on, engine not running, and 14.8 or 15 volts, and it wonders what the hell is going on. So let's clear the code out of the radio. Check it again. Okay. Let's try and clear the code out of the ABS. Oh, let's clear the code out of the OnStar. Alright. And let's try manually clear the code, because last time the network code clear didn't clear the code. Let's see if it's gone. And it is. So next, let's see if the transfer case control module works. Let's try it. Transfer case data. Transfer case command position. Let's see. Let's try it. 4 high locked. That's what it's in right now, according to this. That's auto. That's 4 high. Auto. 2 high. So there's no more warning lights on the dash. The transfer case seems to shift fine. It's in 2-wheel drive now, so I'd say that this one is repaired with that one 5-volt reference wire to the transfer case position sensor. And the nice thing about it is we didn't change any parts. Well, an electrical terminal. Thanks for watching.